So let's just get right to it. Our next presenter is Dr. Sheri Strydhorst, an agronomy research agronomist with Alberta Wheat and the Barley Commission. And her topic is crop rotations as a tool for reducing uncertainty. Sheri is an agronomy research specialist with the Alberta Wheat and Barley Commissions, a position she began in February 2021. In her role, she's working to build stronger relationships with researchers. She provides support for developing funding proposals to help align producer-funded research with grower needs while upholding strong scientific rigor. She works with an extension of research findings and also coordinates the regional variety trials to provide data for new variety performance for the provincial seed guide. And with that, I'll turn it over to Sheri.
Thank you very much, Ingrid. And it's really nice to be here. This is my second opportunity to speak at the Manitoba Agronomist Conference, and it's great to be here. I think on the topic of uncertainty, John did a great job of introducing it and that concept of the age of uncertainty with high input costs, high crop prices, and the like. But I think the one thing that was missing that I will touch upon in that list is the policy uncertainty that we are faced with and the implications for the agronomic decisions that will result from that. So I will start with the presentation here. I just want to acknowledge my very important co-authors here. They're all critical for the data that we're going to look at in today's presentation, but Quy Lu, who is the scientific lead on this presentation with Agriculture and Agri-Food Canada at Swift Current, and then also Catherine Stanley with the University of Manitoba, who has provided me some very specific Manitoba data that we will look at in this presentation. So what I'm going to cover in today's session is a bit of background. Then we're going to do, I was kind of thinking of that Christmas Carol theme with rotations in the past, rotations in the present, and rotations in the future. And that section on rotations in the future, we're going to look into some research learnings and biophysical resilience of our crop rotations. I think we've had so many examples of drought stress, heat stress, and we need to look at resilience in our systems. And if we have a minute, I'm certainly happy to answer questions. And if we don't get to those, my contact info is available and I'd love to chat with you. So the background is that crop rotations are becoming simplified. I think we all know that. Simplifications are the result of many factors. Workload and farm size. I think we have all seen the trends of farm sizes getting larger and fewer people being involved in food production. So to make that work, there needs to be specialization, and that results in some of the simplification to get that specialization. There's the ease of management piece. When you think if you only have a wheat and a canola rotation, the knowledge that you need for just managing those two crops, you don't need to know about staging of soybeans or staging of corn. It is simpler. And there are just all of these really good reasons for why our cropping systems are being simplified. But, I think we do sometimes have to look at the bigger picture. The economics, and while this is, the fourth one on my list, I think it's probably the most important one. Farmers are all running businesses, and if they are not productive and making money, they can't be doing simplified or diversified rotations. So that becomes incredibly important, is that every decision made on farm in terms of the cropping system that's implemented needs to consider the economics, and money has to be made at the end of the day in the business, and that is a driving factor. Logistics and equipment, if we go back again to just a wheat canola rotation, there's certain equipment that you need for that. If you start diversifying into, even adding winter wheat into it, the logistics of that complicate the harvest of your crops. If you start getting into another crop type like dry beans, you start needing different equipment. And this is not simple, and that's why we do have simplified rotations. So our Western Canadian farmers are being pressed to increase yields while reducing inputs. There are federal government targets to increase exports, and at the same time, farmers are being told to use less nitrogen fertilizer to reduce greenhouse gas emissions. And those are, I see as very competing concepts. And what do we do to help achieve those goals and, what is realistic. And we do need to produce food, but we need to be environmentally mindful of that production. So I think crop rotations can be part of the tool to achieve that and remain economically viable. So we need to understand them a little better. Now, this will start with crop rotations of the past, and maybe this is a little too far past, but in preparing for this presentation, I did look through my previous slide decks and came across one on crop rotations from a direct seeding advantage conference that I presented at 14 years ago. And I think there's some slides in here that maybe hold some relevance and maybe get us thinking about that bigger picture and some of the benefits of more diversified rotation. So low diversity systems have reduced potential for species interaction. And there I think we can think about insect pests and insect predators and needing both of those in our system. And that requires habitat for those insect predators and parasitoids. So that's one piece that we lose when we simplify our systems. There's altered nutrient cycling rates and efficiencies when we take pulse crops out of our rotation, and there's very good reasons to do that. For example, on our home farm, peas are not part of the rotation because of the lodging issues that we have with it. But then if you take that out, you don't have that nitrogen fixation piece. And if you have a very simplified rotation and don't have different rooting depths, then you're not able to access nutrients at different depths of the profile, moisture at different depths of the profile. And as we simplify our rotations, there is more and more dependence on humid management and inputs. And I know there's a ton of input and management going into our current systems, but sometimes we replace knowledge with, inputs, and maybe we can do a better job of merging the diversity of our system with our inputs to get better input use efficiency. So some of the elements of successful crop rotations, I think it's including that fertility building crops and fertility exploiting crops. I think I recall someone mentioning, if we had only pea crops, that certainly wouldn't be a good thing for the system. I can't imagine the weed and disease issues we would get into. But if we don't have any peas in our rotation or other pulse crop types, then we do lose out on that. We talked about crops with different rooting systems, different rooting depths, deep rooted versus shallow rooted, and then also fibrous versus tap roots. They are accessing different nutrient and moisture profiles in the soil. Then we have crops with varied pest and disease susceptibility. I'm from central Alberta, kind of clubroot country. And when we have those rotations, and sadly we do have rotations that are, some fields are continuous canola, we get the clubroot issue, and we get it to the point where the genetic resistance that we have against clubroot isn't robust anymore, and that resistance is breaking down. So when we vary up our crop types, we can vary our disease management and our pest management. We need to mix weed susceptible and weed suppressing crops. If we go back to peas again, they might be a crop that doesn't compete overly well with weeds. And, if we were to grow continuous peas, we'd have buildup of weed issues. And then winter soil cover, I think, is becoming increasingly important as a topic for us to be thinking about. It's certainly a challenge. I know getting winter cereals into our rotations isn't easy. There's other winter crop types that are being played with, but that winter survivability is a challenge in the logistics of planting that. And then we layer in the complications of cover crops. So while these are elements of a successful crop rotation, they're not necessarily easy or economical to put into our system. And that's where we have to find a way to make this work. So now we're into crop rotations of the present, and this is a field from home this year, and you can see it's a zero-till field, and there's canola planted into wheat stubble. So it does a great job of showing the zero-till that is increasingly, there's used on a ton of acres across Western Canada. I think we don't maybe get enough credit for that, or the value of that, what farmers are doing for that. But this also highlights that tight rotation of wheat to canola on many farms. So if we start looking at some of the stats, this is Manitoba seeded area by crop type from 2016 to 2021 StatsCan data. And I want to kind of highlight 3 different rows here. We've got in yellow here the canola, and it is in 2021, canola was seeded on 37% of the acres in Manitoba. Our next big one is spring wheat here, seeded on 30% of the acres in Manitoba, and then soybeans on 14% of the acres. So in Manitoba, these 3 crop types are accounting for 81% of the seeded area. And, you know, in Alberta, we are really not that much different. So we maybe have a flip-flop of wheat and canola. Here, wheat is on 37% of our acres, canola on 31% of our acres. We have some considerable barley production and some field peas. And together in Alberta, these 4 crop types account for 92% of the annual cropped area in Alberta. And in general, our cropping systems are very simple and they are lacking in diversity. And, you know, this is wonderful data from Manitoba Ag Services Corporation. And if you haven't seen this, I'd encourage you to check it out and take a look at it. Here's the website at the bottom. This here is your stubble type, and this here is the crop planted into that stubble type. So across in this diagonal bar would be the spring wheat seeded on spring wheat. So 2% of the acres of spring wheat are seeded on spring wheat. And I think ones that really stood out for me was that 14% of the soybeans are seeded onto soybean stubble, and 10% of the navy beans are seeded onto navy bean stubble. So I think we can do some work there, but that's what the situation is. And this is the implications now of those tight crop rotations. So if we look here in this box, the yield of spring wheat seeded on spring wheat is only 85% of that average. And certainly that is concerning. Winter wheat, even more troublesome there. The yield there that's being achieved is only 66% of the total. So you can see this concerning trend of cropping one crop type on top of the other. But then we look at canola or wheat being seeded into canola stubble. That's that baseline. I think that's very much driven by the percent of acres of wheat being grown on canola stubble. But there's some nice examples here. When peas are grown on canola stubble, the yield is 104% of that target. So there's definitely opportunities to, you know, arrange our crop rotation so that we can have yield improvements. But at the end of the day, our Western Canadian cropping systems are still really lacking in diversity. And there's many good reasons for this, but what is the best way to implement diversity in our system? And I think that's where we get to the future. And I think this driverless tractor is really a great visual of where we need to go, and improving our cropping system diversity is part of that. So now we're going to get into the research that was conducted across Western Canada and with a specific site in Manitoba. Now, the objectives of this are to look at the best, and the best is the most productive, resilient, and economical cropping system in multiple ecozones across Western Canada to improve nutrient use efficiency. And I think that goes and touches upon some of those scary policies that we're hearing from the federal government on potential limits on fertilizer use. Enhancing our system resilience. How does our system handle, and how do we get productivity in a drought system or with abiotic stresses? For example, this year, wheat stem softfly in southeastern Alberta and southwestern Alberta, southeastern Saskatchewan was a huge problem. And how do we deal with these biotic stresses? And then we have these bigger picture issues like long-term soil health, reducing carbon footprint, but all of this has to be driven by farm profitability. If the farm is not profitable, we can't achieve all of these other wonderful goals, and that is going to be a constant theme here, is that profitability. So here I've got the sites of where these trials are being located across Western Canada. So Beaver Lodge in the Peace, Lacombe, Lethbridge, Scott, Saskatchewan, Swift Current, Melfort, Saskatchewan, and then our site at Carman, Manitoba. Now you say that's great, but how do you have a rotational trial? The same crops don't work in all those environments. So when we look at the rotations in Beaver Lodge, the control rotation is wheat, pea, wheat, canola, but that's very different compared to the control rotation in Lethbridge and Swift Current, where it's very dry. There it's a fallow durum, barley, durum rotation. And if we zone in on the Carman, Manitoba site, the control rotation is wheat, soybean, wheat, canola. And just you'll notice that there is nothing in 2018 here, and that's just contracts were delayed. So everything in Manitoba is a little bit later. So we have a little bit less Manitoba data that we are able to look at in this. So these are the cropping sequences used at Carman. Now, I do want to go through these in a little bit of detail. The control is Brandon wheat, soybean, Brandon wheat, Liberty Link canola. Our pulse or our oil seed one, and this is going to be a bit of my spoiler alert here. This rotation, we're finding it to be about 7% higher yielding, and it's nice and stable. And we'll look at system stability, and that's where we have soybean, CWRS wheat, soybean, canola. Our diversified system, and the spoiler alert there is that we're seeing some nutrient use efficiency in that system. And I think part of that might be tied to this winter wheat phase where we have that crop over winter. Our market-driven system, and in this rotation, the crop choice is actually determined based on spring commodity prices. So, and what would make the most money. So the first 2 years of the rotation are corn, followed by oats. We've got a system here with no nitrogen fixing crop, only cereal crops, no broadleaf crops. So what implications are that in the long run? Then we have a high risk, high reward, which is corn, pinto bean, canola, sunflower. Highly variable is the spoiler alert on there. And then the green manure system that has a green manure plow down of hairy vetch and barley, a fall rye, a corn soybean intercrop, and the canola pea intercrop. But when you don't have economic returns from that green manure in the first year, there are profitability concerns with a rotation like that. So really, when we look at the results from this study, it's important to understand the rainfall at Carman. And I think you guys in Manitoba understand this much better than me. But when we look at the rainfall during the growing season from May to August, 2019, 61% of the rainfall, 55% of the rainfall, 71% of the rainfall. So we do have much drier than typical growing conditions, and couple that with above average heat. And, there are implications for the yields. And when we look at now, I popped up the yield data here. When the wheat is yielding 38 bushels, that's really tough to be profitable. And that's important parts of this conversation. So when we want to compare the yield of rotation A versus rotation B, it's really challenging to do because we have so many different crop types. So what Qui has done as a concept is what we calculate is the canola equivalent yield. And I want you to understand what that concept is. Now, this is calculated to compare the system production at the cropping system level. So what we do is we calculate the price of the non-canola crop. So if we said it was wheat at $12 divided by the price of canola at $20 times the yield of wheat. Now that would give us our canola equivalent yield, and it allows us to compare yields across crop rotations. And just to hit this point home a little bit further, the canola equivalent yield for canola is 1, because the price of canola divided by the price of canola is 1 times the yield of canola. So that's the concept there. Now, these are the canola equivalent yields at Carman. And I think immediately everyone's eye is drawn to these tall bars. That looks great off the top. So these here, if we pop that up, the high risk, high reward rotation that is corn, dry bean, canola, sunflower seems to have these extremely high canola equivalent yields. And the corn oat rotation also looks pretty impressive, but you can also see there's a lot of variability in this system. And we're not really factoring in those long-term implications for this. So again, what's driving, I think, those really high bars would be these high corn yields relative to our canola. When we're calculating that canola equivalent yield, and canola is only yielding 20 bushels, that's maybe why these do look so inflated. So, that's the Manitoba perspective, but I think it's very important that we also look at data from across all the site years that we have. Averaged across all site years, these are the trends that we're seeing here. And I think the important thing here is we'll pull up the yellow box around the market-based system. This is the highest yielding system that we have, but I think there's a lot of variability in this system, and there's risks of outbreaks and degrading soil health when we have just a corn oat rotation. So certainly some risks there, but maybe the second choice is the better choice, and what seems to be performing well is this pulse or oil seed based system. So this rotation averaged across all the sites we have in Western Canada is 7% higher yielding, and it has the benefit of that nitrogen fixation. It has the benefits of soil biodiversity, reducing the carbon footprint, and system sustainability. So in the Manitoba context, that soybean, Brandon wheat, soybean, canola, which seems to show some certain benefits. And as no one might be surprised, the high risk, high reward in the green manure system were the lowest yielding. Now, looking at this increasingly important nitrogen fertilizer use efficiency. So here what we've got, this is calculated as the grain yield divided by the fertilizer applied. And you can see this gray bar is sticking up in many sites as being kind of a winner, and that's the diversified system. You'll notice the Carmen site, it is short a year of data, and I think we need a little more data to fully understand this, but across our bigger data set, it's this diversified system. So this figure here is that compilation of all sites. That diversified system is standing up as having good nutrient use efficiency or nitrogen fertilizer use efficiency. And I think that's very much tied to this winter wheat piece and having soybeans in that rotation. Another consideration I think that's incredibly high on people's priority list is the precipitation use efficiency, making the most of the rainfall that we get from that seeding to harvest time window. And again, similar setup. Carmen here is only 1 year of data, so a little bit of caution there. But when we look at all sites combined here, you can see that those top four, the conventional system, or our check, our pulse or oil seed, our diversified system, and our market driven system are all quite high and quite similar. So good benefits there. But we are seeing, poor performance with that high risk, high reward and that green manure system. And that's certainly something that needs to be factored into these situations when rainfall can be less abundant. We need to make the most grain from the rain we get. And those are maybe some of the losers in this system. Now, the system stability, the coefficient of variation is what we use to kind of wrap our head around this. And I have a bit of a decoder here. A large CV means less stable. So when we have yields and coefficients of variation that are below this dash line, that means they are more stable, and above this line means they are less stable. So when we kind of look at what's showing up in the different quadrants, we see that the green manure system is very stable, very predictable in terms of yields. So you can see here yields range from the low to the high there. The problem is the yields are low, and we need to pay bills at the end of the day. The next, we have the high risk, high reward system. And this one might be the least favorable because it's the second lowest yielding system and the most variable. You can see there's an extreme range of yields in that. And we've kind of got our cluster of these three that are below that dash line in terms of being rated as quite stable. And I want to draw your attention really to this pulse and oilseed one that is higher than average. So as I mentioned, that 7% higher yields, but also that stability. So, we love the high highs that we can get with some rotations, but we sure hate the low lows. And having predictability in our system, I think, is something that is going to become more and more valued. And just to hit home again, that what that pulse and oilseed rotation is in the Manitoba context is soybean, wheat, soybean, canola. So now I'm going to be wrapping things up. The preliminary findings from this research is that to achieve that high productivity and sustainability, what we're seeing at early stages are that in high yielding zones, like what we see at Lacombe, where this was from the end of July, things really looked pretty good. The focus should be on maximizing yields through managing crop and biotic interaction. So managing the diseases we would see in an environment like that. And then we have those low yielding zones like what we saw in Lethbridge, Swift Current. And I'm not quite sure where Carmen falls here because before this study would plunk it in the high yielding zone, and now with some of the rainfall issues you guys have had, I'm not sure, but here in these low yielding zones, it's important to understand that those impacts on drought and make sure that we can get yield even under drought conditions, and what rotation will help achieve that. So in terms of yield for our average system yield, again, we've gone through these, the market driven system and the pulse or oilseed intensified system. This is based on 14 site years of data. We have another 9 site years to add at the end of this growing season. That will help, add more power, more confidence in what the most stable and best yielding systems are. I think it's really important that, this market driven system, while it is the highest yielding, and in Manitoba is corn, oat, what are the impacts on soil health and pest outbreaks when you don't have a legume in there, when you have only cereal crops, when you don't have a broadleaf crop? What are the long-term weed implications and things like that? The green manure system is low yielding, but what are the impacts on soil health and the benefits of diversification? And again, this is, early in the cycle, and it's a ways through, but we need to see what the study says at the end of the day. So to sum up, yield stability, that market driven system is less stable. The pulse and oilseed system has that good balance between yield and yield stability. The diversified system has nitrogen fertilizer use efficiency. We have on precipitation use efficiency, maybe some less good systems, and we still need to really understand the soil health and economic inputs. And with that, I know I am at the end of my time. There's some more resources if you want to learn more. Need to acknowledge our great funders. And with that, there's my contact info.
Thank you, Sheri. You covered a tremendous amount of material and really gave everybody a lot to think of. And thank you so much for comparing provinces as well. There is one question, and perhaps I'll get you to answer that just by typing it afterwards so we can keep on time. But certainly appreciate all the information. Terrific job. Thanks so much.
Thanks very much. I appreciate being here.